Today, I have a motor speed controller. This board is actually a motor speed controller of a centrifuge. So, let me first give you a background. What is a centrifuge? So, this is a centrifuge, a very old centrifuge. So this is used in a medical field. This is used in laboratory to separate substances on lesser and greater density by the means of centripetal acceleration. So this is the another centrifuge that already open. This is the motor. So again, this is the board, the speed controller of the motor, and it is consist of three parts. This board, this potentiometer, and the indicator. I separate the indicator from that board because I have already made an initial check-up of this one, and I found out that the problem is coming from this board. So this potentiometer, this one, is actually connected here. Like this, and this indicator is only LED. It is connected here. So the problem now is that this board does not work. If it is connected to the unit, it don't rotate, or I mean it don't run the motor at all. So the main unit is not with me, but I have here a motor, this one. I tied the motor here so that when it is running, it will not move. So I will use this motor to confirm if this board is really not working. And after that, after I fix this one, I have to test this board by connecting this motor. Some of you might ask why I am fixing this kind of equipment. It is because that by profession I am a biomedical engineer, and I am working in a hospital and in a company. So I am dealing with medical equipments actually. So first, let me show you the motor. And this is not the exact motor, but the purpose why we have this motor is only to test this board. And after we fix it, we will use this motor also to try if we are successful. So I tie this motor in the wood so that when it is running, it will not move. So this is connected direct, this cable direct to the main power, to 20 volts AC. So it's nice. the motor is running using direct power to 20 volts AC. Now we will try to connect this motor on that speed controller board and let us see if it will work or no. So now this is the motor. See, this is the wires, and I connected it here. So one of the cable is going direct to the main supply, and the other one is going to the motor here. So you will position it like this. We will try to give power so that we will see if this one will work or no. So this is the potentiometer. It's connected here. Okay. I will give the power now, and let us see. Now the main power is connected. As you can see, this is the feet of the triac, and there is a light so that you can see better. Look at that. There is 231 volts in the two terminal of the triac, and our motor is still not working. Even if I rotate this potentiometer, to adjust the speed, nothing. So here from this point up to here, you see there is 231 volts, and as you can see, the motor is slightly rotating, but it don't run continuous. It's stopping. So it means from this one, look at this, the second pin going here, we have also 231 volts. It means there is a voltage going to the input or the gate of this triac, but still it don't make the motor run, because as you can see, this terminal 1 and terminal 2, the power is still not connected, because if it switch on the gate, I should not get 231 volts here. This will become short to allow the current from terminal 1 to terminal 2 to pass. It's like a wire. It will become like a wire. So there should not be a voltage there. But why, even we have a voltage on the gate, why it don't switch on our triac? So it could be the triac is defective. It could be this diac, this the blue one, is defective. It could be another else, or maybe these two trimmer. So I will remove this and we will check the components one by one. But by the way, just to show you again that, see, if I put here my multimeter, there is some current from the probe of my multimeter, which the motor is slightly rotating, but again, it don't run continuous, it's stopping. It cannot maintain a small current to on the gate. So I will remove this one and we will see. As you can see, nothing. But we do have the voltage also here. We do have the voltage, but it's not working at all. So I will remove the power and let us troubleshoot the board. Okay, the first thing is, let me remove this potentiometer and this one. Let us try to check first this one. So now the multimeter probe is connected there, and let me have a view here because there is a light. Okay, like that. There is a light. So this, my meter is on ohms mode, or I mean resistance mode, and I will try to rotate this one. Just look. Now this is 0. This is the minimum speed of the motor. We have 0.5 ohms, and I will rotate. As you can see, the resistance is increasing. Sorry, by mistake. This is the minimum. The higher resistance, the slower the speed of the motor, and the lesser resistance up to 0, this is the maximum speed. So it means that this potentiometer is working fine, this one. So now let us check another components on the board. Here we have a triac. By the way, my meter is on resistance mode, and this is the triac. Let's put the black probe to terminal 1 and the red or positive probe on terminal 2. Okay, as you can see, we get nothing. Wait, just for a while, let us make it in good position so that it is clear for you. Let me have this one. How about this? Okay, so just look at the probe. We got OL. So this is the first indication that the triac is okay. The next thing we have to do is to short this terminal 2 in the gate, and we should get some high resistance reading like this. As you can see, we have 0.395 K. See this one. 0.395K. By shorting terminal 2 in the gate, this is one indicator that our triac is okay. Next thing is the fuse. Supposed to be this is the first one that we will check the fuse. But anyway, see, the fuse is okay. The second is let us see if there is any open resistor. We have to check this. Oh, we are in diode mode. Let's go to so we have 14.9K, and from here we have 27K. So our resistor are okay. This diac, I already check it when there is a power. As you can see, the voltage have crossed from this terminal going here and is going to the gate. See, so we got here from this point going to this point up to that gate of this triac, we got 231 volts. The voltage has passed in that diac going to the gate of the triac. So probably this diac is okay. So the next thing is, let's check this one. Okay, meter in resistance mode. Let us check this. We got 63.9K. At this point, we have 0.1 ohms. We have 63.9K. How about this one? It's reading OL. Okay, as you can see this, I will make it a little higher since it is dark. So let us see if there is anything we can use. Not lower the camera like this. Okay, so again, why we don't get any reading here? Meter in resistance mode, measuring the resistance of the trimmer. There is nothing. To the pin, there is 0.1. Again 0.1 going here, OL. So let's check it on the back side. So this is the one, this one from here, OL, to this one, OL, here 0.1, and this is what? The other one is 200K. The other one is 100K. So seems like this one is there is no resistance for this one. Let's try to, but this one is 100K, so if we measure the continuity, I think we will not get the continuity for 100K resistance, and I doubt this trimmer. So let's try to remove this one. It's written here minimum, and what's that? Minimum. It's written here maximum, max. So most probably this trimmer is used for calibration of the speed, because the centrifuge, there is some certain speed, or yes, the speed, like I mean the RPM. This is used to calibrate the RPM, like if you have a setting like 4000 RPM, 3500 RPM. So I think this is used to calibrate. Yes, this is the one. So let's try to remove this and let us see. Let's try to remove this. This is the one. So now this is the trimmer. See, it is showing 100K. Now let's try to read if we can get any resistance after we remove. We'll put here. Now from here, this 2 pin, still we got OL. Oh, sorry, this is little. Here we got OL. How about here? OL. How about here? We have 70. I have here another trimmer, 100K. Let's see. And this 2 pin, we have 81K. 81K. This pin 41K, and this one 45.5K. This is, by the way, 100K. See, 104. So this is the one that we removed from the board. This 2 pin OL, this 2 pin OL, and this one we have to around 70.6K. So not all the pins is giving the resistance. So the connection in this board, so it don't allow the current to pass between this one going here, because it's open circuit. This is the one. See, So let's try to connect this trimmer and let us see if it will fix our problem, or do we have another problem. Let us see. So it's done. We solder it. That's it. So the next thing we have to do is to test. And let us see. Okay, let me connect this to the motor and let's try. Now this is the board, the motor speed controller board. We replace this one, the trimmer, and I already connect to the motor, and this is the potentiometer. So let me try to give power first and let us see. So as you can see, now the motor is running. So we confirm that the trimmer is defective. But it does not end there, because this is a motor, or I mean a motor speed controller board. So we have to run the motor and adjust this potentiometer, and it should change the speed or the RPM of the motor. So that is the only way we can say that our repair is successful. Okay, let's try now. So as you can see, when I rotate this potentiometer, it reduces the speed of the motor, and that is minimum. Lowest. I will increase the speed now. Okay, the speed now is increased. As you can see, the RPM of the motor is very, very fast. So I will reduce again. So it's very low now. Again, increase. And decrease. Okay, so now let me off this one. So after we replace this defective trimmer, we were able to fix this motor controller board. By the way, I forgot one thing. There is a light indicator for this one. Let's try to connect this one if we can get a light here, but it doesn't matter anymore because this is only an indicator. The main thing is this motor is working with the speed or the RPM adjustment. Okay, before I will connect, let me double check if I remove the power of this one, because this is to 20 volts and it is dangerous. So I just got the vaccine for corona to survive, but if I got electric shock here, so there is no vaccine for that one. One mistake could be fatal. So it was removed. Let's connect this one now. So when I on this one, we should get a light from this one. This is only an indicator that we have a power. So let's move this one a little bit. Okay, let me give power. Okay. So now we are able to fix this motor speed controller board of the centrifuge. I need to hand over this one to the owner so that he can connect this to the centrifuge, and the calibration will be up to him. In biomedical engineering, we are doing preventive maintenance of the equipment. So for the centrifuge, to make sure that it is giving the correct RPM, we have a tachometer to measure the RPM, and that one we have to compare on the set value of the centrifuge. And if something is not much or there is a big difference on the RPM, then we have to rotate this trimmer, this one. We have to rotate this trimmer to match the set value of the RPM to the one that is read by the tachometer. So that's it for today. Thank you very much for watching, and I hope you learned something about this board. And don't forget to like, share, and subscribe. Good day.